So today we are going to derive the derivative of tangent x. So it turns out that the derivative of tangent x is secant squared x, or secant of x squared. But we're gonna derive this fact using the quotient rule. So the first thing we're gonna do is we're gonna look at tangent x and ask ourselves, what is tangent x? What do we define tangent x to be? Well, tangent x is sine over cosine. So this is sine over cosine. And why did we do that? Well, notice now that this right here, we got a numerator and a denominator. This right here is a quotient. So to find the derivative, we could use the quotient rule. So taking the derivative, we're going to use the quotient rule. So it's going to be low d high minus high d low all over low squared. So it's going to be low, which is going to be cosine x, d high. So what's the derivative of sine, the high, the numerator? So the derivative of sine is cosine minus high d low. So the derivative of low, the derivative of the denominator. So the derivative of cosine is negative sine. This is all over low squared. So this right here is actually our derivative. So now this just becomes a matter of simplification. So cosine of x times cosine of x. Well, that is just cosine of x squared. So this right here in blue is cosine of x squared. But a little note here is, so that's cosine of x squared, is we typically write this cosine of x squared, we just write this as cosine squared of x. Which that's like something we do with trig functions just to make them easier to write, because it's annoying to write the parentheses and put the square up here. It flows a lot smoother if you put the square right here. So cosine squared of x, we just write that as cosine squared, or cosine of x squared, we just write as cosine squared of x. So the negative, then the second term, we have a negative and a negative, so that's going to be a positive sine of x squared. And this is all over cosine of x squared. So now the next step is look at this numerator. We have cosine squared of x plus sine squared of x. So there's a really important trig identity. So let's recall, hopefully you learned about it in pre-calculus, that sine squared x plus cosine squared x is equal to 1. And addition is commutative. It doesn't matter the order that we add things in. So this right here is the same thing as sine squared x plus cosine squared x. And we know that that is equal to 1. So this whole numerator is just 1. Isn't that pretty amazing? So our derivative is 1 over cosine squared x. Now we wanted to show that this was equal to secant squared x, but we have 1 over cosine squared x. How do we make this look like that? Well, what we do is we write cosine squared x as cosine x times cosine x. And from here, we split the fraction. So this right here in pink is our first fraction. So we're going to split this into the product of 2 fractions. This is our first fraction. So 1 over cosine x. And this right here in blue is our second fraction. So you can imagine that there's a 1 there. So our second fraction is also 1 over cosine x. And finally, what is 1 over cosine x? That's secant of x. So 1 over cosine x is secant of x. So we got secant of x times secant of x. And that is secant of x squared.